Okay, so let's continue on. So property number 4 looks like the following. What if I had 2 squared raised to the 3rd power? 2 squared raised to the 3rd power. So the way I would solve this is I would say, well, PEMDAS, so I start inside the parentheses, then I go to the exponent. 2 squared is 4 cubed. 4 cubed, 4, 16, 64. Notice 2, 4, 8, 16, 32, 64. This is the same thing as 2 to the 6th power. Right, if I'm raising an exponent to a power, I multiply the exponent. So if I am raising an exponent to a power, I multiply exponents. So general form, x to the a raised to the b power equals x to the a times b. And here we have rule number 4. Oh, I put 4 up there. Why don't you write it? Done. Let's take a questions here. All right. Let's look at rule 5 now. So rule 5 says, how would I solve this question? 3 raised to the negative 2 power. 3 raised to the negative 2 power. Dulce?
You would do 1 over 3 squared and then you would 1 over there, whatever.
Right. So if you have a negative power, you flip it. So this is in the numerator. So this is going to be flipped. So I have 1 over 3 to the positive power. Switch this, bring the negative downstairs, make it positive. That'll be 1/9. Joshua. Yes, with the positive exponent. Yeah. Now, this works the other way too. If I had 1 over 3 to the negative 2, if I had 1 divided by 3 to the negative 2, that equals 3 to the positive 2, which equals 9. So you flip the negative exponent and bring it upstairs, or if it's upstairs, you bring it downstairs. So let me write this. If the exponent is negative, flip the exponent from numerator, I'll put NUM, to denominator. This pen is dying. Need to go back to Walmart and get some new pens. Or from denominator to numerator and make the exponent positive. So this is rule number 5, and the mathematical way of writing this is the following. X to the negative a equals 1 over x to the positive a. Any questions on properties 1 through 5? All right, we can pick up number 6 here. Number 6 says, if I have the problem 2 times 3 cubed, 2 times 3 cubed, and I'm purposely writing it out this way because I want to illustrate the rule. So most of us would say, okay, let me start inside. Let me get 6 cubed, so let me get 216. Right? Any questions on how we got this much? But if these were actually like variables, we would have like no idea what they are. So you can solve this simply by distributing this 3. So I get 2 cubed times 3 cubed. 2 cubed, 2, 4, 8. 3 cubed, 3, 9, 27. 27 times 8, 7 times 8 is 56. Carry the 5, 2 times 8 is 16, plus 5, 216. Joshua.
That works if you have variable and regular numbers, right?
And regular numbers, right. So if I had 2x cubed, it would be 2 cubed times x cubed. So to write it out, if there is an exponent outside the parentheses, distribute the exponent. So by way of example, if I have x, y to the a, that equals x to the a times y to the a. And you must distribute this a to like every single term in the parentheses. So if I had 3xy, let me write this. Another way to write the rule is if I had this, the a must be distributed to each term. You don't just do it to the variables. You do it to every term. Whether it's variable or number, it doesn't matter. Questions? Okay. Let me model problem 9 on the homework. That's probably like one of the hardest ones from this section. So those who already did it, who are already working ahead, that's great. If you haven't done 9, I'm going to do that right now. Let me move this back to the other board. So can we pause this, Sergio?